we provided you with is an overview dashboard of what your distribution network would look like under our proposed hybrid solution. Going from top to bottom, we first provided you with two maps. The first one showing you where each distribution center is and how much demand is flowing through each distribution center in a year. Next to that, we included a map of all of your different end customer locations, color-coded by the DC center or transloading facility they're being serviced by, or whether they're being shipped to you primarily directly. Underneath that, we provided a few key metrics that we believe are important to better understanding your distribution network, including production time in months, annual demand in pounds, and number of rail cars annually. Below that, we included much more specific information organized first by DC assignment / direct shipments, end customer city, material name, and then included individual specific data for each of those combinations. One thing that we've built into these dashboards as well is the ability to drill down specifically into different data. So as you can see here, you have the ability to filter on production facility, material name, and DC assignment. You also have the ability to click into this report down here onto either DC assignment, ship to city, material name, or any of these other values, and have the dashboard automatically filter itself based on those selections. What we provided you with was a cost savings analysis dashboard to give you a better sense of what your cost savings would be and where they're coming from. So going from top to bottom again, we first provided you with two similar looking maps to the last dashboard. The first one showing you each distribution center as well as what their potential positive savings are from our proposed model. Next to that, we have each of your customers broken out in addition to breaking out their potential cost savings and losses using our proposed DC model. Next to that, we have broken out your cost savings by two metrics. The first one on top is breaking out what % of your volume is contributing to positive cost savings, and below that, it's just comparing the overall positive versus negative savings you would recognize by using a full DC model. Underneath that, we broke out your cost savings by a few other metrics. So in this first chart, looking at the positive and negative cost savings at each distribution center compared to the overall quantity being shipped out of each distribution center in a year. And next to that, we included what we called our savings ratio, which is essentially just the positive or negative cost savings divided by the overall quantity in pounds of material that are contributing to those savings. Next to that, we included what your cost savings look like by each classification of goods. So just a quick recap, as you can see in this, our Class A goods made up about 77.26% of your total dollar value, followed by B products, which made up 13.33%, and C products, which made up about 10% of your overall quantity being shipped. So we included the overall savings and losses you'd recognize within each of those classes, as well as the same ratio we discussed in the last chart as well. And like in the other dashboards, we also included much more specific information underneath that you can scroll through and click through at your leisure as well. And like all the other dashboards, they have the ability to be filtered either on savings or losses, as well as any of the information in this underlying chart. Another thing that's important to recognize in this Tableau is that if you wanted to drill down into any of these specific underlying reports, all you have to do is click on the report, click on this little icon, and it'll take you to that specific sheet for that report.
Now on our transloading dashboard, as you can see, our first map over here, we have all our end customers and which transloading facilities are located closest to the end customers, and the size of these circles represents the total annual demand. The chart on the left, or the graph on the left, shows all the transloading facilities in the US, and the ones highlighted in red, as you can see over here, here, and here, are the Anaheim, Houston, and New York transloading locations. And the chart on the bottom shows what the annual demand is by state based on which production facility, based on where the products are produced. And so if you click on any of these facilities, it goes to or any of these points, it goes to the actual website, as you can see here, and this shows where all the transloading facilities are located. Anaheim dashboard, the first chart we have looks at the production by each material in Anaheim, and then on the left we have the Anaheim reallocation. This just shows where these materials are produced in other locations. So when we look at the charts on the bottom, we can see this reallocation chart just graphed out where each material is produced, and then on the bottom chart it shows that where these materials are going for each distribution center. And if we just hover over one of these materials, for example, material 210, it changes the charts to show specifically where material 210 is produced and where it's being shipped to. And for each material it switches. For example, for material 71, these charts change to show different results.
Main dashboard we provided you with is kind of a cost breakdown dashboard. So as you can see in these top 3 charts, we broke down your total cost of using distribution centers into 4 main costs between material plus overhead costs, rail holding costs, rail transportation costs, as well as discrete rail cost. And we broke it out. This is just breaking it out on an annual basis. The chart next to it, we're breaking down on an annual basis these costs, breaking them down by each distribution center that they're being distributed to. And then below that, we broke them out by each material from in ascending order of most to least expensive materials. And then on the bottom line, we included the chart that shows the correlation between cost savings ratio, so the total cost savings divided by total quantity, versus the distance from each distribution center to each end customer. And as you can see, while the R squared value is relatively moderate, there does appear to be a correlation between how far away the distribution center is from its customers to its versus its overall ability to generate savings. And the last chart we provided you with shows the breakdown of these same costs from a month-to-month basis, just to show you how consistent or inconsistent the breakdown of these costs is over time. Include our Tableau instructions. We just have a few additional considerations you need to know about for when you move this into actual Tableau instead of Tableau Reader. So the first one is the data source it's pulling from. As you can see, it's pulling live from an Excel sheet, pulling from the cost analysis and data tabs. And one thing to consider is when you update the data in the Excel tool sheet we provided you with, you will then have to go and find this spreadsheet that we're providing you with and copy and paste all new data and cost analysis values into the bottom of each of the sheets respectively as values. Once you do that, you go back to Tableau, click on Data, and click Refresh. And that will ensure that everything in Tableau is now the most up-to-date information. The second major consideration you have to have with this is based on the way these two spreadsheets work and the way the data is being pulled in, you're looking at a situation where a lot of the values are going to be double counted. So just waiting on Tableau to process. But one thing we did to account for this, so basically if you were to just use all of these different measures as is, you would get very high numbers due to the fact that certain things are being double, triple, quadruple, and I think even 5 times counted in some cases. So we created a formula to create future calculated fields to ensure that nothing is being double counted. So everything with distinct at the end of it is these formulas. So if you look into the formula, we used a fixed formula with origin material and DC assignment, basically saying that for every DC assignment and origin material grouping, to take the average of every value that we're looking for to essentially guarantee that we are not double counting anything for those groupings. So whenever you want to use a new value that we don't currently have one of these distinct equations for, you're just going to have to go into anything that says distinct, copy it, change the name, and then change the measure value that's being pulled into this average, and you will be able to see the correct value without having to worry about any of it being double counted. That's it. Thank you very much for a great semester.